It is a tool that harnesses EEG waves for mood and speech communication, giving voices to individuals who have lost it, specifically using the open BCI ganglion headset. Take Davey, for example. He was diagnosed with ALS and gradually lost all motor function, including the ability to walk, speak, or make facial expressions. There are many disorders that impact motor neurons across the entire body, impairing speaking and motor control. A lot of patients report that they feel their identity and self-expression is hindered with diagnoses that impair their independence. This is where NeuroScribe can help. First, we utilize mood detection as a basis for text prediction and also as an indicator for the listener to convey tone. Then the user's imagined movements will be detected to allow users to perform word selection hands-free. NeuroScribe uses 3 main models. In general, we have EEG models for mood detection and imagined movements, and 3 categories of text prediction models. Mood detection was trained by testing users' reactions to images and categorizing them to negative, neutral, or positive. Each of these 3 moods corresponds to a specific language model, which proposes words that better matches the user's emotional state. This makes sentence creation more seamless and efficient. Finally, our 3rd model uses EEG waves to make selection of word choice hands-free. Users are told to imagine moving the word block up, down, left, or right to choose their selection. In general, NeuroScribe aims to help people like Davey to communicate and gain back their sense of identity and independence. This tool can be harnessed in daily communication, recreation, and clinical settings to improve individuals' quality of life. Thank you.
Can you hear me? Okay. Hello, everyone. I am Harrison, and with me is Rose, Alvin, Kevin, and Hillary, and we're the team behind NeuroScribe, a hands-free mood detection and text generation tool. For our presentation, I'd like to do a live demonstration using the OpenBCI ganglion headset and try to make some sentences with NeuroScribe. So the first thing that I have on screen is a previously generated sentence, which was using brain signals. So it detected that I was in a negative mood, I guess stressed, and the sentence that I generated, or that ended up being generated, was only says has thing I say see, which isn't a super legible sentence, but with further training on the direction detection algorithm with EEG data, we'll be able to have much more accurate sentences. So first thing, I will just refresh and we'll generate a new sentence live. So the first thing it does is, using the EEG headset on my head, it detects the mood. Again, it detected negative. And what it does is, at each time point, so every 2 seconds, it suggests the 2 most probable words that would come next in the sentence according to the language model associated with the mood. So I guess because I'm talking, it's still grabbing, it's taking actions. But at each time point, you have 4 actions. Up and down select the top and bottom words. Left refreshes the words and shows you the 2 next most probable words. Sorry, I'm stuttering here on the screen with him, my. And if you think about moving the block to the right, then you move on to the next word. So while we have a lack of training data, so our machine learning algorithms aren't super accurate, I will demonstrate I'll just quickly demonstrate what it's like if you have more accurate responses using.
Yeah, just wanted to make a comment. The reason we initially just wanted to do EEG straight to text, but the literature and what EEG can do, we've noticed that imagined movements, they have pretty concrete brain areas associated with them, like the premotor cortex or the superior temporal sulcus area. So it's more concrete to use EEG as movement and selection tool rather than straight text to speech or EEG to speech, which is why we decided to go this route to make something that is plausible and not just theoretical.
Sorry, I've got shaky hands here. touchpad is not great when you're nervous. Right there? Okay. Okay, so what this does is it allows us to just use the keyboard to input instead of using the headset. It still uses the headset to detect the mood, however. So if I refresh, it'll detect the mood. And now it's using the neutral model. So at this point, it suggested 2 starting words, so it can use type or then. I guess we'll see what we can get. So we'll start. These aren't great starting words, so we're going to refresh them and try to get 2 more more useful words. Oh. So we'll do school. You tell me if there's a good one. School for. There's a few I guess bugs that we will fix in the future. If we had more time to suggest I guess more relevant words, we would be able to train better language models. School for night. Difficult is a relevant word.
Life.
Difficult life. And then we'll just end there. School for night, weeks, difficult life. Yeah. So it does take data from the EEG headset and it processes it and it feeds it into a machine learning model. The downside right now is just we do not have enough training data, but given enough time, we would be able to train data, improve that accuracy, and have more correct directions and decisions. Thank you.
Thank you. Yes, I do have a question, and more of a procedural question, which is, for the demonstration, did you not just consider sort of limiting your sentences to subject, noun, noun, verb, object kind of sentences to begin with, so they would sort of give you the right categories of, I did that?
So in the earlier demo, it detected a negative mood, and when it does detect a negative or positive mood, the sentences do make a lot more sense because it will reflect positive and negative words such as happy, joy, and then negative sadness. Don't words that make a lot more sense. Since this is using the neutral model, it is bound to make less sense because it's a combination of the positive and negative data together, and also just the training was just far too limited. We only ran 10 epochs for each model, which is really not optimal. So if we did have more time, we would have definitely trained the model a lot more, and it would have increased the accuracy a whole lot.
And am I right in understanding that then the goal of having the model become trained is that it does sort of allow a person using it to communicate to, better recognize their mood, better know the types of things that they want to say, better perhaps know the people that they might be talking about, so that, yeah, okay, I see nods. That's